Okay, good afternoon, everyone. Last few classes which I have posted on our group, we discussed various signal conditioning devices in those last few lectures. As you all are aware, we are into Unit 2, and initially we started off with operational amplifiers. So we discussed few of the amplifier circuits, how those can be used for signal conditioning. We saw summing amplifier, we saw integrating amplifier, we saw instrumentation amplifier. So few of the amplifiers we studied in the previous lectures. Then we studied some of the protection devices like opto isolators and some other circuit protective devices. And thereafter, we discussed some of the ADCs, analog to digital converting devices, various methods of A to D conversion, then various methods of D to A conversions. We also saw some of the digital logic fundamentals. We saw some of the gates commonly used, logic gates, those are used, AND gate, OR gate, NOR gate, NAND gate. So all those aspects we studied, and thereafter we discussed few data acquisition devices, that is DAQs, in the previous classes, and various other filtering circuits we discussed in the previous classes, wherein some unwanted signals those are received from the sensor transducers, how those are filtered using electronic filters. We saw low pass filter, high pass filter, band pass filter, variety of filters we studied. So all those signal conditioning devices we discussed briefly. Now we are going to see some of the data representation devices. If you just recall, in the initial lectures, when I showed you the generalized block diagram of the Mechatronics system, we had sensor transducers, then we had signal conditioning devices at the input stage, we had the signal conditioning devices at the output stage, and then we had the controller part, and there we had one option, either to send the conditioned signal to the controller and actuator, or send this conditioned signal to the data representation systems, or send the signal to both. Like if you just take an example of a deep freezer or maybe a refrigerator, let us say. The refrigerator is a typical example of a mechatronic system where the control action is purely mechatronic. When the temperature is sensed by the temperature sensor, that sensed signal of the freezer temperature is sent to the controller, and the controller appropriately decides whether the actual temperature inside the freezer is equal to the set temperature value. If not, it will just put the compressor on or put the compressor off. Simultaneously, in some of the high-end refrigerators, you'll find the temperature indicator also, digital temperature indicator. So the control action, mechatronic control action, is automatically taking place. At the same time, whatever is the temperature data that is displayed, maybe by using a LED display or maybe LCD display, whatever type of displays those are desirable, those are used. So in some of the refrigerators, some of the deep freezers, you'll see the temperature indicator, right? And you, from that indicator itself, you can change the set temperature value, and then the control action will also take place, and the temperature display will also take place. Similarly, even on the CNC machine tools, the machinability data, the control action is automatically taking place by the CNC controller, but at the same time, on the screen if some data is to be represented. Maybe what is the cutting speed? If the operator wants to check what is the cutting speed, what is the spindle speed, what is the feed rate, right? So that data can be used for actuation of the signal, actuation of the actuator, or it can also be used, and it can also be used for display of the machinability parameters. So there my data representation systems come into picture. So data representation is also equally important part of mechatronic systems, because let the case be of a pharmaceutical industry for that matter. So along with control action, I want the display also. If the reaction chamber temperature in a pharmaceutical industry, the reaction between two chemicals is taking place, you have maintained the concentration, you have maintained the flow rate, you have maintained the temperature, you have maintained the pressure, and the process is going on. But if I want to see what is the composition, if I want to see what is the inside temperature, if you want to see what is the actual pressure inside the reaction chamber, then the same signal will be used for display of the controlled parameter as well. So data representation is also equally important. And in these lectures, coming lectures, we'll be discussing various data representation systems. And in some cases, along with display of data, the data is needed to be recorded also. Right? In a continuous process industry, let us say, I want display. So the supervisor will just see. Suppose it's a milk chilling plant, and periodically he'll just see and observe the milk temperature, and he'll make a note of it. Fine. But if I want, if the top management wants the data for the entire day, what are the temperature variations, right? So that signal will be sent to a recorder. Either it can be a computer, or there are many other recording devices as well. So that data can be recorded and later on used for analyzing what has happened throughout the day, right? So either I can have a display of the data, and I can have the recording of the data also, right? So measurement systems or mechatronic systems consist of three elements. First, the sensor transducer, then the signal conditioner, and then display or data presentation element. Traditionally, they have been classified into two groups. These are the indicators, as I told you, indicators and recorders. Indicators give an instant visual indication of the sensed or transduced variable, while the recorders record the output signal over a period of time and give automatically a permanent record of the recorded data. So first of all, we'll see the indicators or displays devices. So displays, we'll see. This is a typical 7-segment display. You must have seen even on your mobile set, even the calculators, the 7-segment displays you can see. As you can see, I can have one element, second element, third element, fourth element, fifth element, sixth element, and seventh element. So these are the 7-segment display, we call it as. You must have seen this typically in your calculator, right? So this is a typical liquid crystal display, right? So A, one segment, B, second, third, fourth, fifth, sixth, and seventh, G, seventh, right? And the binary output, let us just see how the numbers are indicated. As I told you, there are 7 segments. Out of these 7 segments, if particular segments are energized, I'll be getting typical signal display. Let us just see. I have the displays, and the digital numbers are, sorry, the decimal numbers are 0, 1, 2, 3, 4, 5, 6, 7, up to 9. And their binary counterpart is 0, 0, 0, 0, right? 4 bits, right? 0, 0, 0 corresponding to 0. So to display 0, what it needs to do? A, B, C, D, E, F. Apart from G, Remaining 6 segments are energized. So A is on, B is on, C is on, D is on, E is on, F is on, only G is off. So what it will display? 0. Likewise, for 1, what is the binary equivalent of this one? 0, 0, 0, 1. This we already seen in the earlier classes. All right, conversions, decimal to binary, binary to decimal. Right. So for displaying 1, what is required? B and C should be energized and remaining should be 0 or off. So B and C will be energized and remaining are 0. So that 1 is displayed. Similarly, 2, 3 for 2, A, B, G, E, A, B, G, E, and D. 2, A, B, D, E, and G. Right? So it will be showing 2. So similarly, for all the 9 decimal numbers, 0 to 9, I can have equivalent segments activated so that I can get this 7 segment display. Right? So this is one of the types of display. So the light indicators for such displays might be neon lamps, or those can be incandescent lamps. These can be light emitting diodes, or those can be liquid crystal displays. So many options are there. So how these segments to be illuminated either by using neon lamps or maybe incandescent lamps or light emitting diodes, that is LEDs, or liquid crystal display for each of the segments. Neon lamps need high voltages and low currents. It can be powered directly from the mains voltage, but can only be used to give a red light. This is a limitation of my neon lamps. Incandescent lamps can be used with a wide range of voltages, but need a comparatively higher current. They emit white light, and so they use lenses to generate any required color. Their main advantage is their brightness. So incandescent lamps have their own advantages. How about LEDs? Right? Light emitting diodes require low voltages and low currents and are cheaper. These diodes, when forward biased, emit light over a certain band of wavelengths. Right? The basic form of a LED, the light emitted from the diode being enhanced in one direction by means of reflectors. Right? This is a light emitting diode. This is a chip on which this LED is there. Just to enhance that light, reflectors are used. In decorations, in Ganpati decorations, you must have seen those LED lamps. And you can see, if you just observe it very closely, you'll see the LED and then the reflector surfaces over which, so the light appears bright, right? Commonly used LED materials are gallium arsenide, gallium phosphide, and alloys of gallium arsenide with gallium phosphide. The most commonly used LEDs can give red, yellow, or green colors. With microprocessor-based systems, LEDs are the most common form of indicators used. So this is about LEDs, light emitting diodes. We are talking about displays, friends, right? So I think we'll stop for today. And in the next class, we'll see the other types of displays or display elements used in my data representation devices.